Hello everyone, my name is Perla and today I would be speaking about autism spectrum disorder. In this presentation, we'll be exploring the anatomy involved, the physiology and pathophysiology, how autism is diagnosed and treated, and the role of artificial intelligence, and finally, we'll look at demographics and life expectancy. Let's start with the anatomy. Autism spectrum disorder is primarily considered a neurological disorder, meaning it affects the central nervous system, but research increasingly shows it is a multi-system condition. First, in the central nervous system, autism is associated with atypical brain development, abnormal neuron and synapse function, and imbalances in neurotransmitters. This can also link to ADHD, epilepsy, and sleep disorders. Next, the immune system. Many individuals with ASD show immune dysregulation, such as hypersensitivity or autoimmunity. Inflammation and gut immune interactions may also play a role. Speaking of the gastrointestinal system, many individuals with autism report issues like constipation, diarrhea, and abdominal pain. Research on the gut-brain axis shows that GI problems may influence neurological function, highlighting a strong connection between the two systems. Finally, the autonomic nervous system, which controls involuntary processes like heart rate and breathing, may also show dysregulation in some individuals with autism. This can affect stress responses and heart rate variability. Overall, while the brain is central, autism affects multiple systems throughout the body. Autism spectrum disorder is characterized by differences in brain development and function that affect communication, behavior, and social interaction. We see this in brain structure and connectivity. Variations in brain volume, reduced synaptic density, and altered connections between brain regions can change how information is processed. There are also neurotransmitter differences. For example, imbalances in glutamate and GABA can disrupt brain signaling, while differences in serotonin, oxytocin, and vasopressin can affect social behavior. Sensory processing is another area. Many individuals experience heightened or reduced sensitivity to sounds, lights, or touch and may struggle to integrate sensory information. Motor skills can also be impacted, with some showing clumsiness, awkward gait, or repetitive movements. And importantly, both gastrointestinal issues and immune system dysregulation are frequently reported, along with challenges in sleep and circadian rhythm. Taken together, these physiological differences help explain the wide range of traits seen in autism. Now, let's look deeper at the pathophysiology of autism, the underlying mechanisms at the biological level. Research shows differences in brain development. Some autistic children's brains grow faster in early life but then slow down, leading to differences in brain size and cortical thickness. There are also abnormalities in connectivity, increased connections in some sensory areas, but weaker connections in social or communication-related regions. The amygdala, hippocampus, cerebellum, and prefrontal cortex are especially implicated. At the neurotransmitter level, both glutamate and GABA systems show dysregulation, which may explain sensory sensitivities and hyperactivity in neural circuits. Neuroinflammation and immune dysfunction are also observed with activated microglia and abnormal cytokine levels in the brain. Some research highlights mitochondrial dysfunction, meaning brain cells may not produce energy efficiently. Finally, autism is believed to result from genetic and environmental interactions. Many genes are linked to brain development and connectivity, and when combined with prenatal factors like advanced parental age or exposure to toxins, they can increase the risk of ASD. Autism is diagnosed by a comprehensive clinical evaluation. There is no single medical test. Screening tools like the MCHAT for toddlers can flag risk, but formal diagnosis involves developmental history, behavioral observations, and standardized assessments like ADOS-2 and input from caregivers and teachers. While there is no cure, there are many treatments and therapies. These include applied behavior analysis, also known as ABA, occupational and speech therapy, physical therapy, school-based interventions, and early intervention programs. Medications can be used to manage symptoms like anxiety or hyperactivity. Other approaches include cognitive behavioral therapy for mental health concerns, nutritional interventions, and social skills training. Interestingly, artificial intelligence is being studied to support autism diagnosis. AI models such as deep learning networks are showing promise in detecting autism by analyzing facial expressions, eye movements, neuroimaging, and even genetic data. This could make early diagnosis faster and more accessible. Now let's look at some statistics. In the United States, autism affects about 1 in 31 children, which is an increase from the previous rate of 1 in 36. Among adults, about 1 in 45 are on the spectrum. Boys are about 4 times more likely to be diagnosed than girls. There are also differences among racial and ethnic groups, with prevalence being slightly higher in Hispanic, Black, Asian, and Native American children compared to white children. Globally, the prevalence is about 1 in 100 children. Life expectancy varies by severity. Individuals with level 1 autism who require minimum support have a life expectancy close to the general population. Level 2 autism requiring substantial support averages around 50 to 60 years. For those with level 3 autism who need significant lifelong support, life expectancy can be as low as 35 to 40 years. This shows the importance of early intervention, access to healthcare, and support systems in improving quality of life and long-term outcomes for individuals with autism. And here is my reference page. Thank you very much, everyone.